Alright, we're going to do some more examples of the chain rule here. I just thought you'd like to see some more examples. There's really only one good way of learning how to do the chain rule, and that's just doing a bunch of examples of it. We're going to take the derivative of sine 4t to the third power, and remember from last year, this can also be written like this. Alright, so if we rewrite it like that, we notice we have an inside and we have an outside, so therefore we have to do the chain rule. Alright, and the chain rule says we're going to take the derivative of the outside, multiply it by the derivative of the inside. So I'm going to bring my 3 down and I'm going to reduce my power by 1. So I'm going to take the derivative of the outside, sine of 4t to the second power. Alright, well that's half the chain rule. The other half of the chain rule says we need to take the derivative of the inside. Well, if we look at this function, we take the derivative of this function, really, alright, and I explained this a little bit in class. When you type in sine into your calculator, it comes up with a parenthesis by it, because basically what that calculator is telling you is we have the sine as the outside function, it's the outside operator, and we have an inside, which is 4t. So since we have an outside and inside, we have to do the chain rule again. So you can see now how this is becoming a chain rule inside of a chain rule. So I need the chain rule on sine of 4t. So I'm going to take the derivative of the outside, which is my sine. This is my outside. This is my inside. So my derivative of my outside, derivative of sine is just cosine, and I need to take it times the derivative of the inside. All right, the derivative of 4t is just 4. So I say, well, times 4 cosine 4t. So there's my derivative. I can simplify farther. I can multiply this 3 and that 4 to be 12 sine 4t squared times cosine 4t. And that's my derivative there. So I just wanted to show you a chain rule inside of a chain rule. All right. The next one's a little more simple. It's just the basic chain rule. I have an outside, which is my 10 parentheses to the 5th power is my outside. So I'm going to take my derivative of my outside. I'm going to bring down my 5 and multiply it by 10 since it's out there. So I'm going to go 50 times x squared plus x to the 4. I'm minusing 1 from 5. Then the chain rule says since we have an outside and an inside, I need to take the derivative of the inside as well and multiply it by the derivative of my outside. So I'm going to take this times the derivative of the inside, which is 2x plus 1. Alright, if you watched my other video and you wanted to know what I did, instead of using the u substitution, I thought that got a little sloppy a little bit, made people getting confused. If you understood that, I made the inside to be u, so I made u equal x squared plus x. And I took the derivative, du equals 2x plus 1. And that would fulfill our definition of the chain rule, which says, the chain rule says we need to take the derivative of the outside and then take it times du then, the derivative of the inside. Okay? So here's our derivative for that one. And this last example, we did number 21 together. Alright. I made the point that if you wanted, you could do the quotient rule, but now that we know the chain rule, we can do it slightly easier. Alright. Again, we have an inside. Here's my inside. And we have an outside. So there's something in the parentheses. Okay, so we need to do the chain rule. So I'm going to take the derivative of the outside first. I'm just going to bring my 2 down, leave what's in the inside, and subtract my power by 1, so it just becomes 1 then. Alright. I'm going to take it times the derivative of my inside. Well, here, I'll go back to our u substitution. Alright, I'll make u into 1 over t minus 3. Alright. We knew from last year, we can rewrite this, or earlier this year, we could rewrite this as to be t minus 3 to the negative 1. If we flip it over to the other side of the minus sign, or over the division sign, we can just take it to the negative power. Alright, now, looks like I'm going to have to do the chain rule now. I have an inside and I have an outside. So I bring my negative 1 down, and I'm taking the derivative of this because if you forgot what we're doing, this u is the inside, and we need to take the derivative of the inside times the derivative of the outside. All right? So we're taking the derivative of the outside here. I'm going to bring my negative 1 down, and I'm going to leave my inside the same, and I'm going to reduce my power by 1, which is to say I'm going to subtract 1. That makes this a negative 2. And then I have to take it times the derivative of the inside. The derivative of my inside, well, I can take the derivative. All right, well, the derivative of t is just 1, and the derivative of negative 3 is 0. So that disappears. So we're just taking it times 1. All right. So now what I have, I'm multiplying by a negative t minus 3 to the negative 2 power. Oh, okay. Well, I can simplify this. I can multiply my two constants out here. So I have a negative 2 up top. This negative 2 means that we can flip this to the bottom. So, okay, so I have a negative 2 up top. I have a 1 t minus 3. Whoops. And then this negative 2 means I flip it back to the bottom to make it back to a positive 2. And now I can multiply, right? Just multiply fractions. I multiply straight across. I got negative 2 times 1, which equals negative 2. And then I have a 1 times a t minus 3 times a t minus 3 squared, which is really just t minus 3 cubed. So the derivative of this function over here is negative 2 over t minus 3 cubed. All right. Anyway, that's chain rule. Hopefully these 3 examples help out more to further your understanding of the chain rule. We'll see you later.